video, I will be introducing you to the two-sample t-test. There are two examples we're going to work through, and let's dive into our first example. For the first example, we're given a list of two different genders and their corresponding salaries from the same company, rounded to the nearest $1,000. The question is, are their salaries significantly different? That's a very important question, especially for the fact that we are trying and striving for, and should be striving for, equality in all facets of our lives. But for gender inequality in terms of salary, it's consistently a battle trying to make sure that there is a balance there. So we have the list right here, and you can see that in some cases, females are making more than males, but there are also some pretty strong male salaries there as well, and maybe slightly weaker ones here. It's kind of hard to tell by just looking at that list how much of a difference there might be. Taking a look at the hypothesis test, you can see that it contains the same elements that we've covered in the t-test. There's going to be a first step, stating our hypothesis. The second step, checking our conditions and naming the test, and also setting our significance level. And the third step, we're going to be calculating a t-score and the p-value. And then eventually the fourth step, which would be the conclusion. So to begin with, why are we using a different sort of test? Well, in previous examples where we've had lists of data, we were able to subtract one list from the other. And that was due to the fact that each row contained information coming from the same individual or the same month or the same litter, whatever it might be. In this case, it's a list of men, a list of women, and they're not matched in any particular way. In fact, we could scramble this list right here, and the data would be exactly the same. These two lists are not dependent on each other. You would say that they're independent of each other. Because of that, it does not make sense to subtract one list from the other. So how does this make our two-sample t-test look different? Well, it begins first of all with the hypothesis from the start, which can be written in a couple of different ways. One way is to actually say, we're trying to find out, are the salaries significantly different? So is the average male salary the same as the average female salary? That would be our original hypothesis, our null hypothesis. And then alternatively, we're trying to figure out, are the salaries significantly different? It didn't say significantly higher for men or significantly higher for females. It just says significantly different. So we would write our alternative hypothesis that way. For the second step, you can see that I named the test. It's a two-sample t-test because of the independent lists. The condition checks seem similar enough to you, I bet. Is there a simple random sample of employees? It's yes. Now this is where it gets a tiny bit different. Is the sample size large enough? Well, in this case, since we're doing a two-sample t-test, we don't have to hit a mark of 30. Most textbooks say that 15 would be enough in both lists to run a solid test. So in this case, we're checking, is the number of men greater than or equal to 15? It's no. Is the number of females greater than or equal to 15? It's also a no. Before we leave that second step, set our significance level. I'm choosing 5%. The third step is where it gets also, I would say, pretty confusing, but the good news is there's ways around it. So here's the confusing piece, is to calculate the t-score. One way to accomplish that would be to use this formula here and take the time to plug in the information that we can get from the graphing calculator. So typing in to the graphing calculator, under stat, I already have the lists in lists 1 and 2. typed in. You could go, one way about this is you could go to stat, calculate one var stats using list 1 and get information about the male's average male's salary from the list and the standard deviation. You can repeat that process again using list 2 to get the important numbers that you need for the formula for the female information. So 86.3 for that sample average and 42.8 for the standard deviation. So that's just one way about it, using this formula, which of course you are provided with. And I've done that calculation here on the side right here. Plugging all that information into the calculator. Maybe it makes sense to at least emphasize this before we move on to faster ways to doing this. If the male salary and female salary are the same, then the average male and the average female salary would come out to be 0. And that would be the case here for this particular 2-sample t-test. So around about 1.7 for our t-score. Then you're off to placing this on a t-curve. So 1.7 be round about there. And we're going to shade to the right there to collect our p-value. However, looking back at my alternative hypothesis, you can see that it included a not equal sign. Therefore, we must assume that a miss to the left is just as or miss to the right is just as equal to us as a miss to the left. So we're going to have to also find negative 1.7 and shade to the left to collect our p-value. To do that, we need the degree of freedom. This is where it gets a little bit different, or there's some options for us at this stage right here is how to calculate the degree of freedom. The degree of freedom before was n-1. For a situation like this, in fact, you may as well use this as a general rule for all situations, but for a situation like this, where the standard deviations of the males and the females are close enough to each other, one is not twice as large or more than the other, these standard deviations are relatively close, we're going to pool the data together, which simply means to calculate the degree of freedom, we wouldn't have to use a complicated formula. We could use a very simple one to calculate the degree of freedom. So once again, because the standard deviations are relatively close to each other, we can do something that's called pooling in statistics, which gives us a very simple formula to figure out our degree of freedom. So the degree of freedom here would be the number of males plus the number of females minus 2. So it'd be 20 minus, so 10 plus 10 minus 2 would be a degree of freedom of 18. And that'll help us figure out our p-value. So the p-value would end up being worth TCDF from 1.7 to 1,000 standard deviations with a degree of freedom of 18. And then you would take that number and multiply it by 2. Since we're doing a two-sided test, we have to double the amount of probability. Once that's done, well, I'll show you on the calculator. So it's pressing second and then vars. You'll find the TCDF. So 1.7 comma 1,000 using a degree of freedom of 18. Gives us that much probability, but then again we're going to multiply it by 2 to get about 11% for the p-value, which is a generous amount of probability. So around 11% for the p-value. And then the last step is just to compare that with our significance level. So the p-value is greater than the significance level. Therefore, we're going to reject the ha and be in favor of the null hypothesis. In other words, just from the sampling of 20 employees, we have the impression that the men and the men and the women are getting paid roughly the same. So, okay, now taking a step back and taking a look at that, that looks like quite an enormous mess of work there that's needed. The good news is we can speed up that third step tremendously by using the graphing calculator. So, to show you how that's done, remember, it just doesn't magically happen this way. You have to actually begin by having the lists typed in. So I had list 1, list 2 typed into the calculator. I'm going to press stat and then go to my test menu. And there I'll see a few steps down there in line number 4, the 2-sample t-test. So either using a graphing calculator or a graphing calculator app to do this. We do have the data, or we do have the stats. We could actually just type in the information that we know from our previous work. And you can see that all the answers are actually there, the same exact answers, well, except for that probability right now. Something's not right with that, but everything else that we pumped into that formula is already preloaded onto this. So that happened, I believe, because I did one var stats ahead of time. Well, maybe not. I think it actually just took care of it myself. Another way to get that to show up is to go to the data and make sure that you're using list 1 and list 2. It has the important information there, the t-score and the p-value, and you can see the degree of freedom was 18. Because it's set to pooling the data together, the degree of freedom is 18. There's just 2 more adjustments that I want you to see here. One of is making sure that this is matching the alternative hypothesis, so make sure you're selecting a 2-sided test. And you can see that that brings up the second tail of this probability, pooling, or not pooling, I shouldn't use that word, putting together both of those probabilities to give us the probability of 11%. So going back to the issue of pooling or not pooling, if the standard deviation was so extreme where one was more than twice the other, then you would consider not pooling the data. And if I just shut that off and not pool it, you can see that the impact was very little on this particular case. The t-score, of course, is still the same. The probability dropped just a tiny bit, and the degree of freedom dropped from 18 to 17.72. There's a way to figure that out by hand that involves a formula that is pretty advanced and very cumbersome. So I would recommend definitely using the graphing calculator app or the graphing calculator to do all the work for us. And as far as the issue of pooling goes, I've even heard some recommendations by some statisticians saying to just always pool the data. All right, looking at our second example, just to give you some further clarification on how this is supposed to go, we've got a list of 2 different phys ed classes and their PACER scores from this year. So we've got 3rd graders and 4th grade scores on this phys ed test, which involves a lot of running back and forth. And it should be obvious that we cannot subtract one list from the other, because over here we don't have the same number of 3rd graders as we do 4th graders. So that would be the case where it would be impossible to create a 3rd list. Now, you would be able to subtract one list from the other if there was a connection between this score and this score. In other words, if this was the same student from one year to the next, and this was the same student from one year to the next, if they were matched that way, you would do a matched t-test, or in other words, you'd subtract one list from the other, like we had done, and work on doing a t-test. But because this is a more complicated situation, and because these 2 lists are not dependent on each other because they are independent lists, we're going to use a two-sample t-test. So just to highlight and race you through the parts that probably are the toughest from the test, you would start off by saying, um, is the average third grade score on the PACER test the same as the average PACER test for a fourth grader? Or are the fourth graders significantly higher? Or are if you're comparing these, are the fourth graders' averages going to be significantly higher? So that would be how the hypothesis statements could look. And you can read over the condition checks, noticing that I did name the test that I'm going to use. So it's very clear. The conditions aren't very ripe since it's not a random sample of students, and also our sample size is so very small. Before you leave the second step, set your significance level. Now, to finish this question off, we're just going to race to the finish line by using the calculator app to complete the rest of the work for us. All right, now that my lists are correct on list 3 and list 4, I'm going to just simply head right to the testing menu. So stats and then tests. Find my two-sample t-test. Now it has the information from the very last question still on there. I'm going to go to data and change it from list 1 to list 3, which was the third grade scores. And then change list 2 and set it as list 4. Leave the frequencies as 1. Clicking done. You can see that it has spilled over and given me all the facts without even having to do one var stats. It's set up to pool already. It's given me the sample averages and the sample standard deviations from both grade levels. It's given me a t-score. It's graphed it for me. It's given me a p-value. It calculated the degree of freedom, all by just simply pressing a few buttons. The last thing to do is make sure that my inequality is matching the alternative, and it was that the second group had larger scores than the first, so I'll have to highlight that. So that will actually match my alternative hypothesis, which had a less than symbol, so the shading should be to the left, which is a great amount of probability, about 23%. So all this, and the t-score is about negative 0.8. So simply all I have to do is record and communicate with what I just saw on my calculator screen. So the t-score was negative 0.8. P-value was about, I think it was 23%. Do I have to go back? I might have to take a second look at that. Just make sure it's right. Yeah, it was 23%. And the rest is just copying down what I see on the screen. So here's negative 1. Here's negative 0.8 for my t-score. The shading is going to the left. And that's a lot of probability there statistically. About 23% is shaded. So, well, the degree of freedom was written on the screen already. It would be the number of third graders and fourth graders added together, subtracting 2. So that's why it's the degree of freedom of 24. And that's a nice touch to add that on to your work. So it's very crystal clear of what you're graphing. And then the last part is just to state your conclusion. So once again, in this particular case, the p-value is greater than the significance level. So we're going to reject the ha in favor of the ho, that the third graders or the fourth graders' scores are not particularly significantly higher than the third grade scores. To close things off, just giving you a sneak peek for the homework assignment. This is especially useful for those that can't download the assignment, or for those that are using this video for their own purposes. I've got, you can take a screenshot there if you need to of that. I've got an assignment to distinguish which type of test you would use for each of these two questions here. I mean, these two lists are identical to each other. That's something you should notice. But the way that we handle each question is different. One of them will be a match t-test, and one of them will be a two-sample t-test. You can take a look at that table there and just complete that for your first assignment on two-sample t tests.